When you look up at the night sky, you are not just seeing dots of light. You are looking into infinity. Each of those tiny sparks is a burning sun millions or billions of kilometers away, each with its own worlds, its own possibilities. If you could count one star every second, you would need thousands of years just to finish counting the ones in our own galaxy, the Milky Way. And beyond it, there are not one or two more galaxies, but at least 2 trillion. That means there are more stars in the universe than all the grains of sand on every beach on earth combined. And among all that, floating quietly in a small corner of a small galaxy, there is one blue dot. That dot is our home. That dot is Earth. If you stood far enough away, the entire history of humanity, the pyramids, the oceans, every smile, every tear would fit on that single pale pixel of light. We are smaller than we can imagine, yet our dreams are larger than the sky itself. For centuries, we believed the stars were unreachable. We watched, we wondered, and we dreamed. Then came the first rockets, the first satellites, the first human steps on the moon, and suddenly the sky stopped being a ceiling. It became a doorway that led to everything. But here is the question that truly matters. Are we meant to only visit space or to live there? If humanity has always moved from one land to another across oceans and continents, why should the journey stop at the edge of the atmosphere? Space is vast, beyond measure. Between Earth and the nearest star, Proxima Centauri, lies more than 40 trillion kilometers of emptiness. 40 trillion. If a jet flew at top speed, it would take over 5 million years to reach it. Our entire solar system, from Sun to Neptune, is just a drop in the cosmic ocean. And yet, even within that single drop, there is room for thousands of home-grade orbital cities spinning silently around the sun. This is why space calls to us, because in that endless darkness, there is room for everything humanity can become. Room for new ideas, new worlds, new hope. The air we breathe, the food we eat, the light we see, all comes from space. It is not somewhere far away. It is where we were born and where we are meant to grow. Children of Earth, your generation is the first with the power to truly build beyond this planet. You will not just study the stars, you will live among them. You will design homes that float in sunlight, gardens that bloom in zero gravity, schools that orbit above the clouds. The maps of the future will not end at the shorelines of the earth. They will extend into the heavens, drawn by your own hands. Our planet is beautiful, but it is small and fragile. One day, we must carry its life outward, protecting it by expanding it. We will build cities that circle the earth, glowing like necklaces of light, and farms that harvest the rays of the sun itself. We will plant the seeds of humanity in the soil of the cosmos. And it all begins here with imagination, with knowledge, and with you. The story of the universe is still being written, and the next chapter has your name on it. Welcome to the mission to live beyond Earth. But space is not just big, it's beyond what our minds can imagine. The distance between Earth and the Sun is about 150 million kilometers. That's so far that light, moving at the fastest speed in the universe, takes more than 8 minutes just to reach us. And that's only inside our own solar system. From Earth to the next nearest star, Proxima Centauri, light takes more than 4 years to travel. 4 years for one single beam of light. So, where can we actually build a home in all this space? We cannot just put houses anywhere. Space has no air, no ground, no up or down. We have to choose very carefully where our new homes can safely float. The first option is close to home, Earth's orbit. That's where satellites and International Space Station already live. Here, we get sunlight almost all the time, and it's not too far for supplies or communication. Imagine a ring of bright cities circling the earth like a necklace of light, each one full of gardens and families looking down at the blue planet below. A little further out is geostationary orbit. It's 36,000 kilometers above Earth. There, a space station moves around Earth at the exact same speed that the Earth spins. So it seems to hover over the same spot forever. That's a perfect place for giant solar power stations or hotels in space that always stay in the same place above our country. But there are other special places in space too. Places called Lagrange points. These are invisible spots where the gravity of the earth and the moon or sun balance each other perfectly. Imagine two people holding a rope tightly. The point in the middle where it doesn't move much is like a Lagrange point. If you put a space station there, it will stay steady without much fuel. These points are great places for big space colonies, space gardens, and factories that build things using sunlight and materials from asteroids. Speaking of asteroids, those rocky worlds floating between Mars and Jupiter, they are full of metals and minerals. In future, humans might mine them for iron, water, and fuel. Near those areas, we can build industrial colonies where machines work day and night, powered by endless solar energy. But one very important rule for NASA space settlement contest is this. Our settlements are not built on planets or moons. They must be free in space, orbiting, floating, creating their own gravity by spinning. That's what we call free spin, free space settlement. They are like huge ships that never land but sail forever in ocean of space. Imagine one of those ships made of shining glass and metal slowly turning near Earth, filled with air, light, and life inside. From the windows, you could see both Earth and the stars. One side would always be filled with sunshine, the other side with sunset. No storm, no pollution, no limit, just endless sky all around. When you choose a place for your own space project, think like a space engineer. Do you want your home close to Earth for easy travel, or at a Lagrange point where it's calm and steady, or maybe near asteroids where resources are plenty? Your choice will decide what kind of technology, energy, and materials you will need. Space may be huge and empty, but now that we know where we can build in space, let's talk about what we will build there. If we are going to live in space, we need a home that can protect us, feed us, and make us feel like we are still on Earth. So, how do you design the perfect space home? First, we have to understand one big problem. There is no gravity in space. Without gravity, our muscles get weak, our bones become thin, and even simple things like eating or sleeping become strange. So, our first job is to create artificial gravity. But how? By spinning. Just like a merry-go-round or spinning bucket keeps water pressed to its sides, a spinning space station can press people towards its walls. That pressing feeling becomes gravity. The faster or wider it spins, the stronger the gravity. That's why most space settlements are round or rotating. There are three famous designs you can learn from and use in your own projects. So the first type of design that is preferred is a cylinder. Imagine huge hollow tube, each several kilometers long, slowly rotating in opposite directions inside. There are fields, forests, lakes, and towns. The walls made of thick metal and glass. People live on the inside surface where they look up and they see ground of another town curving above them on the other side of the cylinder. Giant mirrors outside the cylinder reflect sunlight inside, so the world inside always feels bright and warm. The second is a torus, the one that looks like a big donut or a wheel. The outer ring spins to create gravity, and at the center there is non-spinning hub for spacecraft to dock. It's smaller than cylinder but easier to imagine and design. You can fill the ring with homes, schools, gardens, and playground, all with gravity under your feet. The third is the sphere. This design looks like a giant ball spinning around its middle. Inside the curved walls hold the farms and houses, and the top and the bottom can be used for factories or zero gravity labs. It's a simple and beautiful shape, strong, balanced, and filled with sunlight through large windows and mirrors. Each of these designs teaches us something important about engineering in space. We must think about shape, balance, sunlight, safety, and space for people and nature. Next, we need to think about materials. We cannot carry everything from Earth. It's too costly and heavy. So future builders will use metals and rocks from moon or asteroid. Metals like aluminum, titanium, and nickel can make strong shells. Regolith, the dust from the moon or asteroids, can be used for walls and radiation shielding. We can also recycle plastic and even grow building materials using bacteria or 3D printers that work in space. Inside the settlement, we must plan carefully. We need living areas, hospitals, schools, and parks. We need farms to grow food and water system that recycle every drop. We also need transportation system, maybe magnetic trains that move around the curved interior or small flying vehicles for zero gravity. When you start designing your own space home, ask yourself, how will my space settlement spin? How many people will live inside? Where will they work, study, and relax? Where will their food come from? Where will they see the sunrise? Your space settlement can be any shape you imagine: a ring, a spear, a flower. Now that our space home is built and ready, we must give it power, energy that keeps everything alive, bright, and working. Just like our bodies need food, a space settlement needs a steady flow of energy every single second. Without it, the lights go out, the air stops moving, and the people inside can't survive even a few minutes. The good news is that space gives us something amazing: the sun. In space, sunlight shines all the time. There are no clouds, no night, no rain. That means endless clean power waiting to be used. To catch it, engineers use solar panels. These are large shiny plates that turn sunlight into electricity. Some are fixed on the outer walls, while others are attached to long arms that slowly turn to follow the sun. A single large settlement may need thousands of panels stretching for kilometers like silver wing. But sunlight also can be used in another way, by mirrors. Giant mirrors can reflect and focus sunlight into the colony, lighting up farms and homes inside. They can also heat special fluids that spin turbines and make extra power. This is called solar thermal energy. Still, we need backup. Sometimes a colony may pass through Earth's shadow or move behind another object where sunlight cannot reach for hours or even days. During that time, the settlement can switch to battery bank or fuel cells that store energy made during sunlight hours. Some designs even include small nuclear reactors, not dangerous bombs, but clean, well protected power units that can run for years without refueling. All this energy travels through thick cables and control systems that make sure every part of the colony gets what it needs. Power for home, lights, air pumps, farms, computers, and defense shield. A single mistake could mean a blackout. So, power grids in space must be smarter than anything on Earth. They use AI computers to watch every wire and fix problems instantly. Now think about how this energy can also create new industry. Factories in orbit can use solar power to melt metals, make glass, and build machines with zero pollution. Space hotels can use it to power recreation areas and giant observation domes. Farms can use it to run their hydroponic systems and artificial lights for crop. Every watt of power helps the colony stay alive and grow. But energy in space is not just about electricity, it's about movement. Spaceship and cargo pods need energy to travel between colonies. Most future ships may use ion engines. They move slowly but can travel for months using very little fuel. Others may use solar sails, large sheets that catch sunlight the way a boat catches wind. Some will refuel directly from the colonies using water turned into hydrogen and oxygen rocket fuel. Why? You create your project, think about what powers your world. Will your city rely on endless sunlight? Will it have backup reactors or energy storage? How will power reach every home and garden inside? These are the questions. Our ancestors built fires to light cake, windmills to move water, and engines to drive cities. Now we build entire world powered by the sun itself. Energy is life, and in space, the sun gives it freely to anyone brave enough to catch it. When your colony glows in orbit, shining with its own light, remember, it's not just a machine you built, it's a new star in the sky powered by human imagination. Now that our space settlement has power, let's make it truly come alive. People cannot live without air, water, and right temperature. On Earth, nature gives us these things for free. In space, we must create them ourselves. This system that keeps everyone alive is called life support. Let's start with air. The air we breathe is mostly nitrogen and oxygen. In space, there is no air at all, only vacuum. So, in every bit of oxygen inside a space colony must be made, cleaned, and reused again and again. How can we do that? Only one way is to split water into hydrogen and oxygen using electricity. The oxygen is released into the colony for breathing, and the hydrogen can be saved for fuel. Another way is through plants. Just like on Earth, plants take in carbon dioxide and give out oxygen. That's why every settlement needs green areas and farm, not only for food, but to keep the air fresh and healthy. Next comes water. Water is one of the heaviest things to carry from Earth. So, it must never be wasted. Every drop we use must be cleaned and used again. Space stations already do this. When people breathe, sweat, or even use the toilet, that water is collected, purified, and made clean again by machines. In large colony, melted ice from asteroid or the moon can also be used. Big tanks will store water, and pipes will carry it everywhere to homes, farms, factories, and gardens. Now, let's talk about temperature. Space can be very hot when facing the sun and very cold when in shadow. To stay comfortable, a colony needs a careful balance. Special mirrors and panels reflect sunlight and release heat. Inside, air conditioning systems move air and keep humidity just right. Not too dry, not too wet. The walls are like the skin of a living creature, always adjusting, keep the inside just right for the people, animals, and plant. There is one more part, waste recycling. Nothing in space can be thrown away because there is no away. Food scraps, paper, and even biological waste are turned back into useful things. Fertilizer for plants, fuel for energy, or materials for 3D printing. Everything is part of a closed loop, like a circle of life that never ends. Let's imagine walking inside such a colony. The air feels fresh. You hear gentle wind created by fans. Streams of water sparkle under the glass door. Children play in green. Birds fly under an artificial sky that curves above your head. You can see sunlight pouring through giant mirrors, creating a warm glow, just like on Earth. It's hard to believe that outside those walls there is nothing. No air, no sound, only space. When you design your project, think of how your colony will breathe, drink, and stay alive. Where does the air come from? Where does the water go after use? How will you keep everything clean and balanced? Remember, a perfect life support system is not made of machines alone. It is made of teamwork between technology, nature, and machines clean the air, plants feed the people, and people take care of both. Life in space will be like living inside a giant heart, a heart that beats with energy, breathes with oxygen, and never wastes a single drop of life. When your design can do that, your settlement won't just survive in space, it will truly live there.